All right, in 3.1, we're going to go over exponential functions and their graphs. So the definition of an exponential function with base A is denoted as this. So anytime we see a number raised to an exponent with the x in it, that's an exponential function. So a is a number greater than 0, and a cannot be equal to 1. This brings us to example 1. Evaluate the function at the indicated value of x, round your answer to 3 decimal places. So these we would just put in the calculator. So you just do 0.5 raised to 1.2. If you're doing it on the phone calculator, you click the x raised to the y button. So you would put the base number, so 0.5, click that x raised to the y, and then 1.2. Did anybody get an answer? Anybody tried it? .435. Okay, awesome. For the next one, we have 150 times 2 raised to the x. So we have to do what's in parentheses first. 2 raised to the negative 2.5, and then multiply that times 150. So what do you guys get for this one? 26.516. Perfect. So for example 1, all we're doing is plugging it into the calculator. So 26.516. So in graphing exponential functions, our domain consists of all real numbers, always. So just like a parabola or quadratic, an exponential function, the domain is always all real numbers. The range consists of all positive real numbers from 0 to infinity. The graph of all exponential functions of the form f of x is equal to bx passes through the point 0, 1, because when we plug in 0, no matter what this number is, so b can be any number, when we plug in 0 as our exponent, we always get 1. So that's why our y-intercept is 1. So no matter what that b is, our graph is always going to go through this point at 0, 1, unless we had b raised to the x plus something at the end. But anytime it's just a number raised to the exponent, we're always going through 0, 1. So if b is greater than 1, then our function has a graph that goes up to the right and is an increasing function. So here we have an increasing function when b is greater than 1, so this blue line. And then if b is less than 1 but greater than 0, our graph is going to be decreasing. the graph of f of x is equal to b raised to the x approaches but does not touch the x-axis. The x-axis, or y is equal to 0, is a horizontal asymptote. So an asymptote means it gets really, really close but does not touch. So our graph will never touch the x-axis. So we have a horizontal asymptote at y is equal to 0. So this is just all of our basic information about exponential functions. Now we're going to graph. Did I skip a slide? I did. No. Okay. So to graph exponential functions, we're just going to plug in numbers and plot them on our graph. So what should we plug in first? We can plug in 1. So when we plug in 1, we have 3 raised to the 1, which is 3. So our point is going to be 1, 3. So we go to the right 1 and up 3. What else can we plug in? 0. So we have 3 raised to the 0. What's 3 raised to the 0? 1. Anything raised to the power of 0 is 1. So our point is 0, 1. And then what else can we plug in? We could plug in 2, but let's plug in a negative number. Let's plug in -1. So we have 3 raised to the power of -1. What is 3 raised to the power of -1? Yes. Awesome. So remember, a negative exponent takes that number and puts it into the denominator. So anytime we see a negative exponent, it becomes a fraction. So 3 to the power of -1 is equal to 1/3. So we have -1 and 1/3. So our next point's going to be right there. If we wanted to, we could plug in 2. We know we would get 9, so that would be up here. And our graph is going to be like this. What's our horizontal asymptote here? Am I muted? Can you guys hear me? What's my horizontal asymptote?
0.
Y is equal to 0. So it's this x-axis. Our graph gets really close to it but never touches. So our horizontal asymptote is y is equal to 0.
I'm confused. If it's not supposed to touch it, then why is it equal to 0? Isn't it, if it's equal to 0, doesn't it mean it touches it?
Y is equal to 0 is that line. So we have a line. So y is equal
Oh, okay, it's just showing. Okay, never mind.
Yeah.
Never mind, I get it. Okay.
What's our x-intercept? Where do we cross the x-axis? Do we cross the x-axis?
No.
No. Because our x-axis is our asymptote. So we get really, really close to it, but we never touch it. So we have no x-intercept. What's our y-intercept?
0, 1.
0, 1. What is our domain?
All the numbers.
All real numbers, perfect. And then what's our range?
Is it the 1/3 to infinity?
So if we kept on plugging in numbers smaller than -1, we would get fractions smaller than 1/3. So like we keep getting closer and closer to 0 as we go farther left. But we never...
So it would be 0 to infinity?
So 0 to infinity, perfect. And then do we put a bracket or parentheses at 0?
Bracket.
Do we ever touch 0?
Oh wait, no. So it's a.
So it's a parentheses. So we never touch that x-axis. So that's why we put a parentheses. We get super close to it, but we'll never touch. All right, let's graph our second one. So we have 3 raised to the power of negative x. So again, we're going to plug in points. Let's plug in the same point. So negative 1, 0, and 1. When we plug in negative 1, we have 3 raised to the negative 1, so 3 raised to the 1, which is 3. So what's our point here? Negative 1 comma 3. And then next we're going to plug in 0, so we have 3 raised to the power of 0, which is what? Three raised to the power of 0.
1.
1.
1.
So then what's our point?
0, 1.
0, 1. And then next we're going to plug in 1. So we have 3 raised to the negative 1. What is this?
Wait, you mean just 1, right?
1/3.
It's a negative x, so it would be 3 raised to negative 1.
Oh, right. So it's 1/3.
So 1/3. So then what's our point here? 1 comma 1/3. So now on our graph, we're going to go to the left 1 and up 3. Plot our first point. Then we stay at 0, go up 1. That's our second point. And then we go to the right 1 and go up 1/3. Our graph is going to look like this. So what's our horizontal asymptote? Y equals 0.
Y equals 0.
What is our x-intercept?
None.
None. We don't have one. It never touches the x-axis. What's our y-intercept?
0, 1.
0, 1. What is our domain?
All real numbers.
All real numbers. And then what's our range?
0 to infinity.
0 to infinity. Because if we keep plugging in numbers greater than 1, so when we plugged in 1, we got 1/3. But if we plug in 2, we would get 1/9. So the numbers just keep getting smaller and smaller. And it's going to keep getting closer and closer to 0, but it's never going to reach 0. So that's why our range is 0 to infinity. Because we keep getting really, really close to 0, but we never touch.
We're never going to have an x-intercept, right?
I'm trying to think of an example where we might. Because if we had, like, so as an example, if we had 3 raised to the power of x minus 3, this would shift our graph down 3, so then we would have an x-intercept. Because then our graph, we would take this and just shift it down 3 points, so then it would go up there, and we would cross the x-axis. But then our horizontal asymptote would be at -3. So we could have an example where we have an x-intercept. So any questions on these? All right, let's go to the next. So graph the following two equations. F of x is equal to 1/4 x and f of x is equal to 4 raised to the power of x. Draw the asymptotes. So let's start with f of x is equal to 1/4 raised to the power of x. Let's plug in numbers. So again, let's plug in -1, 0, and 1. So we have 1/4 raised to the power of -1, what would this be?
It would be 4.
It would be 4. So then what would our point be? Negative 1, 4. So we go to the left 1 and up 4. Next we're going to plug in 0. So we have 1/4 raised to the power of 0. What's 1/4 raised to the power of 0? 1.
1.
So then our point is 0, 1. So we stay at 0, go up 1. And then next we plug in 1. So we have 1/4 raised to the power of 1, which is just 1/4. So our point is 1, comma, 1/4. So we go to the right 1 and up 1/4. Once we have our 3 points, we can graph our exponential function. Yes. Yes. What would be our horizontal asymptote here?
Y equals 0.
Perfect. Y is equal to 0. So we just put our dotted line through the x-axis. All right, let's graph. F of x is equal to 4 raised to the power of x. What number should we plug in here? Let's plug in the same thing. Negative 1, 0, and 1. So what is 4 raised to the power of negative 1? One-fourth. So our first point is negative 1, 1/4. We're going to go to the left 1 and up 1/4. Next we're going to plug in 0. So we have 4 raised to the power of 0, which is 1.
1.
So we have 0, 1. And then lastly, we plug in 1. So 4 raised to the power of 1 is 4. So our point is 1, 4. So we go to the right 1, up 4, and connect our dots with our exponential function. What is our horizontal asymptote here?
0.
Y is equal to 0, but yes. So it's the same thing.
Yes.
Alright, so on the next slide, we talk about transformations of our exponential function. If we add a number on the outside, add or subtract a number on the outside of our exponent, we have a vertical translation, meaning it's going to go up or down. So our graph is going to either shift upward or shift downward. If we add or subtract a number to our x, so directly happening to that exponent, we are going to shift it left or right. So if we add a number, we're going to the left. If we subtract a number, we're going right. If we multiply our function by a negative, we have a reflection on the x-axis. So if it's a negative on the outside, it's a reflection on the x-axis. If it's a negative on the inside, so directly happening to our exponent, it's a reflection on the y-axis. If we multiply a number by our exponential function, if the number is greater than 1, we have a stretch happening. So our graph is being stretched vertically. If that number is a fraction, then it's shrinking, so it would be like compressed vertically. And then lastly, we have a horizontal stretch or shrink. So if x is being multiplied by some number If that number is greater than 1, it's a shrink. If the number is in between 0 and 1, so if it's a fraction, then it is a stretch. So it's the opposite of what you think when it's happening to the x. Alright, so let's practice some examples of our transformations. So we're going to use the graph of f of x is equal to 4 raised to the power of x to obtain the graph g of x is equal to 4 raised to the power of x plus 3. If we are adding 3 on the outside, what do we think is going to happen to our graph? It's going to go up 3. Well, let's graph them both. So first let's graph our f of x is equal to 4 raised to the power of x. So when we plug in 1, what do we get? 4. When we plug in 0, what do we get?
1.
1. And then when we plug in negative 1?
1/4.
1/4. So our f of x graph is going to look like this. Now let's graph our g of x. So when we plug in 1, we have 4 plus 3, which is 7. So when we plug in 1, we have 7, which we can plot up here. When we plug in 0, 4 raised to the power of 0 is 1, and 1 plus 3 is 4. So we'd have a point right there. And then when we plug in negative 1, negative 1 would make this 1/4 plus 3. We could change this into 13/4, but we could just go up 3 and then 1/4. So 3 and 1/4 right there. So now that we have our 3 points, we can graph our exponential function. So what happened to our graph to go from the blue to the green? What did we do?
Went up 3.
We went up 3, so we were right. It's the same exact graph, but we just shifted it up 3. So now let's find the domain for our blue graph, our f of x function. What's our domain?
All the numbers.
All real numbers. And then what's our range? What is it? 0 to infinity. Well, you would have like one horizontal asymptote for each graph. What's our domain for our green one?
All the numbers.
All real numbers. And what's our range? 4 to infinity. Is it 4 to infinity? How many did we shift up? We only shifted up 3. We see that our horizontal asymptote is at 3. So it would be 3 to infinity. So our horizontal asymptote for our g of x function, the green one, is what? Y equals 3. And our horizontal asymptote for the blue one is y is equal to 0. Any questions here? All right, let's look at our next one. So we're going to use the graph of f of x is equal to 4 raised to the x to obtain the graph of g of x is equal to 4 raised to the power of x minus 2. Find the domain and range for the g of x function. So we just graphed this f of x. We have a point at 4, a point at 1, and 1/4. So our f of x looks like this. It's the same graph that we did on the last one. Now, what do we think this 4 raised to the power of x minus 2 is going to do? Shift to the right 2. Let's see if we're right. Oh my goodness. Okay. Here we go. So for a is greater than 0 and a does not equal 1, if we have two exponential functions, so a raised to the power of x and a raised to the power of y, if our bases are the same, then we can set our two exponents equal to each other. So if we have the same base, we can set our exponents equal to each other. It doesn't work for 0 and it doesn't work for 1 because anything raised to the power of 0 is 1. And then anything raised to the power of 1 would be itself. So it doesn't work when a is, or if we had 1 raised to the power of anything, so if 1 raised to the power of 2 would be 1, 1 raised to the power of 3 would be 1. So it doesn't work for 0 and 1. Alright, so let's look at our examples here. So we need to solve using the one-to-one property, so what we explained on the last slide. Our goal here is to get our bases to be the same thing. So can we get 9 to have the base of 3? Yeah, what would we have to change 9 to be? 3 squared. So we have 3 raised to the power of x minus 2 is equal to 3 squared. So we can just get rid of our bases and set our exponents equal to each other. So x minus 2 is equal to 2. And then we solve for x. So we add 2 to both sides. X is equal to 4. Alright, let's take a look at b. What do you think we have to do for b? Where should we start?
You have to make the bases equal to each other.
We need to make the bases equal to each other. Can we get our left side to be something other than a fraction?
Yeah, it's times both sides by 2.
We
We
can't
can
do
multiply.
that.
We can power it by 0.
So one person said that we should multiply both sides by 2, but we can't do that because we have an exponent here. So we wouldn't be able to multiply because we have an exponent. So because we have to do the exponent first. If we made this a negative exponent, we can flip this to 2 raised to the negative x. So just like how our negative exponent makes it a fraction, we're doing it in reverse. We're making the negative exponent and making it a whole number.
-4.
Can we get 16 to have the base of 2? What would it be? 2 raised to the power of 4. So now that we have the same base, we can cross those out. So we have negative x is equal to 4. So then what's x equal to? Negative 4. Alright, last one. Here, we can't get this to have the same base, because we can't get 1 to have the base of 6. But what can x be to give us 1?
0.
0. So x is equal to 0. This is where we're going to stop for today. We're going to do the rest tomorrow. So your web assign only deals with these problems for today.
You turn in the notes?
Nope, you're not turning in the notes today.